Welcome to Technology and Education. Today I'm Richard Smith.
And I'm Caroline Crawford.
And today we're discussing a new study by the National Institute of Health on how students or young children process math.
I find it very interesting. There's an underlying expectation revolving around developmental expectations. And the ages that they're looking at are developmentally appropriate to leap to a different level of understanding, cognitively developmental understanding. So I find that intriguing, but at the same time, focusing it upon mathematics is an interesting way of doing this. And they're looking at the brain through MRIs.
Yeah, so that this
I'm trying to give you pauses so you can jump in because you're looking like, oh, you just hush. Okay.
No, you're doing so well.
Look at that.
And the MRI factor, I think, is very interesting because up until now we've had a lot of supposition on how students learn
Look at
math.
you and those big words, but that's true. You're right.
And people are on both sides of the issue. And one of the things that this study pointed out is that in essence, the more that the students were able to
memorize and impact their long-term memory through multiplication tables, addition understandings, not having to pull from their short-term memory and work through a problem, but instead moving towards, oh yes, 4 plus 6 is of course 10. Yes, I don't need to think about that. I know that.
Or I don't need to think about. I
don't need a calculator in my hand to figure out what 4 plus 10 is.
Or before calculators, I don't need to count on my fingers.
12 plus 12, 144. Ta-da!
And
12 times 12. Did I
so,
say plus?
Now, so
just ignore me.
I think you said times, but
yay!
But you know, if
cognitive leaps, I forget.
if you take, for example, the idea when students when they go from kindergarten to the higher grades, a lot of them seem to not do too terribly well in math, and there might be a variety of reasons for that.
Absolutely.
But one of the reasons is that there are certain processes which they have not memorized, mastered, that, and without that mastery of those processes, they have to work through the process step by step.
Every single time. I can tell you 12 times 12 is 144. I don't need to think about that because I memorized my multiplication tables. But then the little computers, handheld computers, came into play, and oh, they don't need to memorize that thing. Yeah. I don't know if that's a great idea, but okay. And now we're seeing the results of that.
Well, yeah, I think they were
through MRI tests, no less.
Through 20 or 30 years ago, there was a lot of de-emphasis on multiplication and what has been identified as rote learning. And at that point, the dependence upon memorizing such things as multiplication tables, that was sort of pushed aside in schools.
They were even using fingers to multiply on. I still remember a girl who came down from the north who taught me how to multiply using my fingers. I only ever learned the 9 multiplication tables. 9 times 1 is 9, 9 times 2 is 18. You can just count them out on your fingers. Like, you're counting on your finger. You're in junior high and you're counting on your fingers. What are you doing?
Well, I think there was a lot of that.
But it works, but I was kind of curious why you don't know it already.
Because I think part of the emphasis was on higher level thinking skills and truly understanding what you were doing in mathematics, and that's not really a bad idea, but some things you just need to be able to do automatically. And then once you get these basic things down and memorized, you can move on to higher processing in math, and that becomes automatic.
And to be fair, neither of us are math educators. We are not mathematicians. We are not mathematics educators. I'm just looking at it from a cognitive standpoint.
Well, I'm looking at it from the findings of this study, which indicate that indeed, if you have certain processes down when you're very young,
your brain sparks in a different way.
Right, you're able to process more complicated problems with a greater amount of ease.
Without worrying about the knowledge level, the lower order thinking skills. You already have that down. You understand that. It's a part of your understanding, your long-term memory, which you can pull from momentarily, so that you can spend your time on higher order thinking skills, analysis, creativity, the important components, which at the elementary, junior high, and high school levels, we're learning the lower level thinking skills and then engaging slowly at the higher order thinking expectations.
Yes, and I think, the rationale is that, they can do that with a computer or with a handheld calculator.
That was the rationale for all the reasons, yes.
I think that's being proved now to be not a very valid
I don't know about
rationale.
proved, but there are suggestions wherein the level of cognitive activity is being spent on lower level efforts versus the long-term memory within someone's understanding of the information. They don't have the knowledge base to pull from, so they have to start from the knowledge base every single time instead of just focusing upon, okay, I know what 4 plus 4 is, it's 8, I don't have to deal with that. I already know the response, so now let's worry about the more important aspects of the formulaic representation instead of, now I have to worry about 4 plus 4 is 1, 2, 3, 4. Really? You're going to start out there every single time? Wow. But it uses your brain in a different level, and it's exhausting using one's cognitive abilities over and over in that manner instead of representing it in different ways.
And I think this would carry into other subject areas, and particularly something like writing, where if the students are not taught the principles of grammar someplace along the way when they're younger,
Absolutely.
when they attempt to write, they are going to have to spend an awful lot of time trying to figure out whether the sentences that they're writing are grammatically correct, and in fact may not even be able to identify a non-grammatically correct sentence or poor sentence structure where the sentence may be grammatically correct but just simply not read correctly without that same basic ability to
break down a sentence structure into an understandable framework. We were never taught that when I was going through school.
Automatically.
I'm totally lost.
And do it automatically.
Yeah, diagramming a sentence, I have no idea what you're talking about. I was never taught that because it wasn't important in the 70s when I was going through.
Well, I was never taught to diagram a sentence either.
Really?
But we certainly were taught the difference between nouns, adverbs, and such things as when to use the word and never to start a sentence with and, all those sorts of things, which remained in my background knowledge when I attempt to write now. I don't. There are certain things I do automatically, and I think it's the same sort of principle as we're found with this study in mathematics.
But it's so interesting how now that they have the ability to watch someone's brain spark in different areas and in different manners, especially with the mathematics focus, it's so intriguing at the different developmental levels of children, as well as the differentiation between children, teenagers, adults, how the brain works and where everything is in short-term versus long-term memory and what parts of the brain are actually being implemented at different points in order to come up with similar results.
And of course, you can do all that, and then there are certain things which are just going to fight against you. For example, in the area of writing, Twitter. And for Technology and Education Today, I'm Richard Smith.
And I'm Caroline Crawford. Bye.